All right, let's get started. So, first of all, thanks Brussels for having me today. Today, we are going to be talking about analytical capability architectures, right? Whatever that means. The most important thing is we're going to focus on a journey that's going to take us through the lifetime of an organization and hopefully your analytical capabilities throughout multiple stages. And for that journey, we're going to do like some stops, some concrete stops to tell us whether we're on the right track or not, and see how we can advance forward. I'm John Mousa, and I am part of the AWS Solutions Architecture team. And as a solutions architect, I was always fascinated about this concept of solution architecture. I come from a background of building microservices and enterprise integrations. Since I joined AWS, I started specializing in analytics specifically. And because of this fascination with architecture, I started to see what are the definitions for architecture, to be concisely explaining for people what an architect does. And you always come along those kind of analogies that say architecture is described as a bridge between two realms. And supposedly those two realms are far away from each other. It's business value and the technical solutions that you're providing. And that's true for the most part of it. But I found that most of the activities that I'm doing as an architect is actually about something else. It's working with concerns that I would call them the lalalities, or the software quality matrix. And with those concerns, some of them are like functional concerns that you can really explain to your stakeholders as direct impact on their business. But some of those are actually towards maximizing the value for long-term consequences of the decisions that you're taking today. And whenever we come up with the terms long-term consequences, we face two fears, mostly. First fear is the fear of being locked into something. And this fear manifests itself as, if I adopt this, can I go away from it at a certain point in time? And if I even get over this fear and start like considering some solution, I face the second fear, which is, if I adopted this, am I missing out on something else? And those two fears are like some of the most important, like show of hands if you have had those fears impacting your decisions when you're designing a system or an architecture, right? Something that happens to almost all of us. According to the reports, only the new generation of people are seeing that through social media interaction and stuff, but they should see architects as well. The point is, and this is something that's also like a theme that was described in today's keynote, is that evolutionary architectures allow us to actually adapt to changes. These are things that we can do incrementally and looking at the architecture at certain steps and see how can we move forward to our next step in our evolution. And with evolution architectures, that's exactly what we're going to do. We're going to go through this journey. And evolution architectures usually have something that's called the fitness function, which is the matrix that's going to guide us through going to the next steps. And today, in our talk, we're going to use a simple matrix function, right? First is the people involved in our team happy with what we're delivering for them? And the second is the organization getting the value throughout those steps in its lifetime of adapting analytical capabilities? Those are very basic metrics. Don't apply those for real, right? Those are only for the talk. In reality, you're going to have like deeper metrics throughout your evolutionary architecture. And the journey we're going to take is going to go through mostly 3 steps. As the very first step, we're going to look at the initial step, where our organization is just realizing that it has data, and we need to get value out of this data somehow. At a second step, we're going to look at a functional state, where we have the data, we got the value out of that, but now we want to extend this value to a lot of stakeholders in our organization. Third step is And that's mostly not like a people step, but rather like a scaling step. If we did that, if we got the data and we've got like people to use it, how can we make sure that this is something that scales across our organization in an efficient way? And as mentioned, like if you don't have a scaling problem, maybe you will not be going there. This is something that we're going to see across this presentation, right? What you want to reach in the end is a continuous innovation state. And this continuous innovation state is something that was also mentioned, which is continuously experimenting. This is something that you can only have throughout experimenting, the innovation step. You cannot find the next big thing in an uncharted water until you are able to try it, refine it, and go back and try it again. So throughout our journey, we're going to try to make those steps easier for you to experiment on something, leave it, and don't be stuck in a certain place, right? So let's start then with our journey. As a reverse step, we're going to look at the initial phase. What this means for us, or for our organization, is that we have an organizational landscape. And I'm going to have a very simplified organizational landscape. This is something that we can actually look back and reflect on our own organizations. But mostly, I'm going to use a front-end kind of business function. Like, don't get phased out by the term domain. It doesn't really mean domains as in bounded context or things like that, but you can actually take that as a business function, right? And a front-end business function for you can be like marketing team that is providing value and interacting directly with your customers. Their concern is to understand your portfolio of services and the customers throughout your demographic and know which services are very popular with some of those customers in order to double down on those. On the second business function, we have a back office. And those are the people that are actually concerned with whenever someone wants to do something, I'm going to operate on that order and deliver that order to them. And that's usually like some kind of a back office function that we have in our organization. Throughout this presentation, I'm going to use a retail kind of thing because this is something that's easy for us to relate to, but you can also relate that to your organization. And for marketing people, and for the back office people, they have obvious analytic insights that they want to find today. For marketing, for example, we want to know which products are famous with some of our customers or popular with some of our customers based on demographics, region, all sort of stuff. For the back office, we want to be able to optimize operations because we want to provide first a good quality of service for our customers, delivery on time, for example, but also we want to do those kind of things at a lower cost, per unit, per scale. However, we want to always optimize on those processes in order to deliver a better quality at a lower cost to our customers. And here we see that those two concerns are somewhat away from each other. This function has its own data, and that function has its own data, and they can get that data right now. And that's usually a strategic insight that we want to get. And speaking of strategic insights, let's meet the team at this state. First, we have Buzz from business. Buzz represents some of the most prominent and most available user for us for our analytics landscape. There's a business analyst or sometimes a data literate community in our organization. Buzz usually looks at the data from an aggregate point of view. He would sometimes do some slicing and dicing over the data. He would also sometimes do what-if analysis. But the lens that he's looking at the data from is an aggregate through a business intelligence dashboard. And through that business intelligence dashboard, he considers that as his storytelling kind of tool in order to look at the data and define what would be the strategic direction that he would want to take with the business unit or the products of the organization. On the other hand, we have Tony. Tony represents a data architect. He's using data-specific development tools in order to build those experiences for Buzz. And when he's not busy helping Buzz, what he's doing is that he's also helping other people that are building digital experiences that are data-driven to our customers. Think of those as a mobile app that tells our customer what's the next best thing or how to recommend a better product for them to buy. Right? Those are our two main stakeholders at this stage. And we're going to tell a story. Right now, what Tony is trying to do is that because those are two separate concerns, Tony is building what it looks like to be silos for Buzz, because both of those concerns have two different data sources that they're getting the data from. Sometimes some of the data sources would overlap, but they have two different concerns to begin with, and two different ways of aggregation to look at the data. And this is OK if it serves the organization's ambitions at this state. It's not a bad thing at all. However, we have a story that can show when would that be a challenge. This is our data platform. Tony has built that for Buzz. Buzz is looking at the data from the lens of a business intelligence tool. Buzz also has brought some of his other analysts to look at the data throughout their own dashboards because they have different concerns. And everything was OK so far, until some people started to build new services in the team. And then Tony had to start to ingest those data inside his data platform to present it to Buzz. The problem is those services are becoming increasingly difficult to integrate over time, and we're going to see why is that a problem. Also, they are increasing in size. As we're adopting microservices technologies or whatever technologies that would allow us to scale development, that's now a bottleneck for Tony in order to import data inside the data platform. And if there is one thing that I don't want you to underestimate, is the power of a business intelligence tool, even a spreadsheet in the hands of a data analyst, because they're going to find their own ways of getting the data from the original data source. They're going to get, I don't know, a JDBC URL or something from somewhere. They're going to use that. They're going to grab the data, and they're going to start analyzing the data. Tony feels sad because now he feels that everything that he has built is being bypassed, especially the compliance part. The problem is the other analysts are also finding something interesting. They are having inconsistent insights to what Buzz is getting. There should be like one number to what is the number of customers that we have in a certain region. However, you can have multiple dashboards now, and if you actually aggregate the numbers across multiple regions, you would find that those numbers are not consistent. And this is something that is a symptom of this problem that we're having right now of what I'm going to call split brains. We have two different insights pointing to two different directions. So our Buzz and other analysts become sad. They're not getting the experience that they really want. So is this the right way then to get the data? If we look deeper at the problem, we have our services that have their front ends communicating with an operational database. And we usually use those endpoints to insert and update data and also query data from those endpoints. And they will start to preserve their state on those operational databases. When we are building experiences for Buzz through business intelligence, we actually just go and what it feels like behind the services' backs and take the data out of those services. And that here is a problem because some of those services now are using NoSQL databases or time stream data or whatever that they came up with. And that has a complicated logic, not just for inserting data, but also for querying data, because they have to reconstruct some, from that data that they're inserting, entities that are easily queryable and queryable over time. And when we actually go and just go to those operational stores and start getting the data from them directly, we will have to replicate that kind of understanding again to be able to do the same queries in our business intelligence databases. Is this the right approach then? right? Let's consider, again, the same scenario, but we're going to do something different. We're going to use that endpoint to actually insert the data. And we're going to use a pattern that's called command query responsibility segregation. And this is a pattern that's used to actually ease the development time, right? Enable us to write better code and better services by actually saying that there is a disparity or heterogeneity between the ways that we interact with our operational systems and the way we actually query those systems. So what we're going to do is that we're going to add additional endpoints that allow us to query the data. And those endpoints can be backed up by two things. One, they can be backed up by a virtualization of the data, but in a queryable state to ease for us querying the data. Or they can actually be backed up by a physical data store that's really optimized for querying the data. And the benefit of doing that is that now we don't need to ingest the data just like from those operational stores, but rather ingest the data from those read-optimized stores, or better, from those read-optimized endpoints. There is a lot of patterns, and the most interesting things that we want to do here at this phase is actually ease the ingestion burdens. That's the things that we're going to be focusing on. And there is a lot of patterns that can go along this way. First, we can start building our own CQRS patterns, or we can use some kind of a guided way of doing that. And this is by looking at data stores and using some of their, for example, a lot of the new NoSQL data stores like DynamoDB in Amazon, which is a scalable NoSQL database, allows you to just event source data out of DynamoDB into streams directly. Or if your store does not support that, check out if it is supported by something like AWS Database Migration Service. You can look at the operational store and start streaming data from there as events. Or you can go across the way and find adapters that go to software as a service offerings like, for example, Salesforce or SAP, and then get the data from their data connectors and provide that in an analytical state for you. Or finally, you can do like no ETL at all. For example, with Aurora, there is now a feature that it would move data directly to your Amazon Redshift without you having to do ETL. Or you can also do something with Athena, which is our big data query engine that's serverless, and you can federate access to multiple data stores. But the most important thing is look for ways to ease the ingestion burden. What are the challenges to watch out for? These would be symptoms of not easing the ingestion burden, right? So that you're, for example, using your business intelligence tools, and some of those tools come with capabilities to enable you to massage the data for visualization. But sometimes we use those capabilities to actually build data pipelines. And the problem is that some of those capabilities are bespoke. You're sometimes writing Lua scripts or whatever scripting language, and then they have also their own analytical functions, and then try to migrate away from those, you would basically find that you're stuck there. So try not to do that. Use those business intelligence tools for what they're meant to do, massage the data for visualization. One sign for you to look for things that would not make you locked into something is look for a separation between storage and compute. If you can support something like object storage, that's going to help you down the road, and we're going to see that. If your only option to ingest more data or have more granularity for data is to scale a certain box up, then you're probably logged in. Try to find ways to actually, or signs of this lock-in, and move away from that. Now, we're going to go to the next step, which is the functional, right? And we're going to look now at our organization. Again, we have the obvious insights value, but we have some new people that are coming to the team. And this represents our organization vision to start not just looking in the back mirror and seeing what happened in the past, but rather what can I predict about the future? This can manifest itself into a team of data scientists or some new roles coming into your team, right? An external team or some people being embedded in your team that wants to find those predictive insights. So we have our team, but now we have Barbara, the data scientist. Barbara looks at the data from a different lens from what Buzz looks at. Where Buzz is looking at aggregates, Barbara wants to predict patterns. And if she looks at the narrow context of data, those patterns are going to be super trivial and repeat a lot. So the pattern is going to say, oh, that's something that's happening a lot. So what Barbara is trying to do is that she's going to look at a wide context of data in order for those patterns not to be trivial. So if she's trying to predict, for example, when an order is going to be delivered, she's not going to look just at the logistics of the order, but actually where the customer is. What are the logistics at the warehouse itself? Who's handling the order? What are the suppliers? And if there are some patterns that emerges out of that data, those would be useful patterns that she can provide for Buzz and everyone else. Barbara uses different tools from what Buzz is using because Barbara is using notebooks, and probably she would want to productionalize her insights at a certain point in time, so she's going to use MLOps, right? And now stop me if you've heard this story before. Buzz tells Barbara, I want to predict this kind of logistics problems that I have. And he would say to Barbara, I know that you like working with spreadsheets. I've heard about that. So what I'm going to do is that I'm going to give you an extract out of our database, and then you can find some insights for us. Barbara doesn't like this, and Tony overhears the conversation. So Tony says, Barbara, I have a better problem. I've been integrating all these data sources. Just come, I'm going to onboard you to the data platforms that I've built for Buzz. Tony is also smart. He's not going to use old services. He's going to use the new CQRS way of getting services or whatever adapters to ease the ingestion burden. So he doesn't have problem at ingesting more data sources for Barbara. The problem is, I've never seen a data scientist come to work excited about joining two fact tables with 20-dimension tables to get the context of data that they want. So Barbara actually is a very smart person, and she has a more powerful tool now at her disposal, those notebooks, because it has computational power. So she actually doesn't like what is being presented to her as a consumption experience and gets the data from somewhere else. And again, you probably know the story. Tony feels sad, he's being bypassed. Again, Barbara's getting questionable insights that does not match the reality of things that Buzz is seeing. So what happens is she tries to invent her own things, but eventually she's sad. Finally, Buzz is not getting the experience that he wants from the first place. So also Buzz is becoming sad, right? So what do we do about that? This might look like a traditional medallion data lake architecture, but I want you to think of it more than that, right? So here's the first thing. We're going to onboard data to our, what we're going to call a data platform. And we're going to call it, and we're going to onboard the data to the first layers that we have. But because we want a history of data and a wide context of data, we want this to be cost-effective for us. Then we're going to abstract this layer with something called consumption experiences. This is not the same thing as that. Actually, those consumption experiences can be a lot of things. We can build bespoke services that now addresses the needs of certain users, right? And it's not just bespoke services, it's actually bespoke models. So if we're using a normalized form of data at a certain point, we can actually use a bigger, like one big table model for other stakeholders. But if there's something that we hate more than questionable insights is having to repeat the same stuff over and over again. So we're going to introduce an intermediate layer. This is going to be called the integrated layer. And because we're going to drive a lot of experiences out of this integrated layer, there is a lot of emphasis that we're going to put on it being accessible and interoperable. One litmus test for that is if you can just go to that layer, get the data without having a compute to babysit this layer, just get the data and start working with that in your notebook, given that you, of course, have the sufficient permissions, right? It's not that anyone can do that, but given that you have sufficient permissions, you can do that, then that's an open and interoperable layer. Because actually, that's what every consumable kind of experience is going to try to do, is you're going to try to go to the data and present them in a way that's suitable for the stakeholders. If you have a barrier interacting with that layer, then this becomes your barrier for flexibly providing consumable experiences. And this is what we want to run multiple experiments. Check out for something. If a consumable experience does not work, we can just swap it. We don't have to commit now long-term for a consumable experience. The point here also is that we're going to look at how these layers can serve different stakeholders. Barbara, for example, can now look at the data from the staging layer and the integrated layer. By the way, they don't look like buckets, as like by coincidence. You can actually think of them as object storage buckets, right? But Barbara can now have her own consumable experience that can look at the data in the staging layer or in the integrated layer, because she wants to use that context of data, through the lens of something that would provide her virtualized ad hoc query patterns for big data, like Amazon Athena, and then use that from her notebooks or other productionalizing machine learning capabilities. Tony can now look at the integrated layer and think of new KPIs or new digital experiences that they can provide for the customer. He's going to be interested in that layer. And he can look at the layer from the lens of, again, interacting with the data on an ad hoc basis. These are not planned queries. This is something that he's going to try, test, and see if it works or not. So we want something cost-effective for us. Buzz can look at the data from a laser-focused point of view, right? His aggregated view of data. And again, we can power that from a cloud data warehouse like Amazon Redshift, and power that through the dashboard experience that he would want to see. Amazon Redshift also integrates natively with your data at an object storage as an S3 bucket, so you don't really have to do a lot of fiddling to get that to work. Right? You can get started with that experience. If you don't like it, you can swap it at any point of time. Finally, if you're building smart apps that want to get the data in a certain way, we have to consider that those users are consuming those applications from APIs and mobile devices. They're not going to wait for a big data tool to actually query the live data. So sometimes we actually cache the insights for them into a NoSQL database, for example, because the access pattern is that I, as a user, want to see the insights that were developed for me. And then we can use something like DynamoDB to cache those insights as a consumable experience, and then power that through whatever API layers that we would want. You have a lot of options for serverless services that can make you experiment and think if that's the right consumable experience or not. And if it doesn't work out, again, you can swap it. And that's the most interesting part about this layered architecture. It's not just about having a medallion data lake to aid the data pipeline. It's actually something that you can use to your favor. Make it work out for you. What are the things that you can watch out for? Of course, if you're trying to look for one box that would deliver all of those experiences, that's not going to work. We have different service level objectives for people that are consuming the data. If you try to satisfy them with just one box, you're either going to try to scale it beyond what it's intended for, or be actually satisfied with subpar granularity of data. The platform team that is building experiences and building the platform is there to facilitate the presence of those platform experiences, not to own the data itself. So you have to make sure that even though that the platform team is providing experiences, that's something organizationally that you can look out for, that they're not the ones who determine what gets there and who actually consumes the data. So that goes to the third point, which is this is a consumer-driven kind of thing. So involve those stakeholders that's going to consume the data in your conversations about the data platform. Don't just assume that you're going to use whatever that you're providing and they have to adapt to that. Now, for the last step in our journey. And in this last step, let's look at the organizational scale. Again, we have those two domains, but now they're somewhat closer together. Because we're going to have our obvious insights, right? We need those anyway. But then we have found that we need something else. We need now a differentiating value that comes from integrating the data from those two domains. And I can give you an example. If you go to Amazon webpage to buy a product, you see the inventory page that lists the product and lists its availability. And hopefully that product landed on your screen because you searched for it or it was recommended for you. So this is something coming from the front end business function, right? It's trying to serve you as a customer. But then you're going to see something at the right that says, if you order this product by a certain time, you're going to get it at that time. That's an approximation of what's going to happen in the back office. And this approximation doesn't just is a random approximation. It takes into account your shipping address, where this product is located in a certain data warehouse, and the last mile delivery options for you. And it can present you options sorted by those approximations. So those are predictions that's based on combining the data about you and the data about fulfillment, right? And that's a differentiating value. And there is a lot of examples for that in your organization. Like, for example, you can find a unified search experience. Or you can look for fraud detections that's going to look at multiple facets of not just how you're looking at stuff, but also how you're fulfilling stuff continuously, right? And this is now the differentiating value, the quality of service that your organization is going to try to provide for your customer once it gets past the initial insights value, right? But still, you have multiple people that want access to your data, right? We don't forget about those. And on top of those, your organization might be expanding. You can have additional subsidiaries. Or you can have additional verticalization within your organization. You're expanding now just not to handle sportswear, but also you're looking at digital wearables that can be consumed with sports. Not a very good example that I'm not doing sports, but yeah, that's examples that I came up with. But here you're going to see that there is not a problem of people. You're going to see that this is a problem of the organization. And this will be constantly expressed by leaders in the organization saying that we think that the compliance is being bypassed, generally, right? Or we don't have actionable insights that is consistent together across multiple organizations. Or finally, we think that the data is there. We know that we know something about our customers somewhere, but we cannot use this data. However, if you don't have this problem, and that's a theme actually that we heard in the keynote, if you don't have that scaling problem, you don't have to go there. It might be just fine that you look at the organizational landscape, at the problems, and then address those problems there. But here we're going to see how the previous steps helped us. Let's look at, like, we're having those two domains. One domain would want to consume this data from another domain, and we're purposeful about that integration. We know what's the value use case that we want to get out of that. And if those two domains were smart, and they listened to our advice before of using this layered architecture, we probably can see where the data integration is going to happen. We can take the consumable data from one domain and then ingest it in another domain, right? But also, if we're building this platform over some technological platform that allows us to virtualize the data without really moving the data around, this can be another option for us, maybe even a better option for us to integrate the data. Again, given that the data quality is the same and the data models somewhat adhere to each other, then we can do this kind of virtualization of data. That can work for a point-to-point interaction, but what if we have multiple data platforms that we want to integrate? Now, that's the thing that we need to consider now, a hub and spoke approach. That's a typical integration problem. And we usually do that by doing those data marketplaces. There is a lot of mechanics about how a data marketplace can work. But what I want you to think of the data marketplace as an actual marketplace. And it has three main roles. First role is a consumer role. Those are people that want to consume the data. And in an actual marketplace, you want to see a variety of products because this drives the quality and the price of those products. In reality, maybe we don't have a variety of data sets. Maybe we don't have a lot of realities about who the customer is. But what at least we want to provide for those consumers is high-quality data. And also, it has to be a frictionless experience for them. They need to look at the data and just be able to determine for themselves whether that's of the right quality for them or not. Based on that, they can consume the data. The producers also have incentives. In an actual marketplace, they're putting stuff on the marketplace because you're getting monetary value. So make sure that you also translate that in a marketplace experience for data. That can be as simple as telling producers, these are the number of consumers that are consuming your data, or even going deeper by telling them, these are the people that consume your data, and these are the actual values that you're getting out of the data, and aggregate that for them. Finally, getting this value or aggregating this value for data is very important for the last role, which is the operator of the marketplace. Those are the platform teams that are building a marketplace for you. And without an incentive that says, this is the values that we're providing for our organization, this marketplace is not going to be sustained. At best, it's going to be, I don't know, left over at a certain point of time. So you have to work out around those incentives and think of your data consumption experience from that point on as a marketplace. One last thing that we want to talk about is that within those platforms, a platform encapsulates all the data models inside and the data architecture inside. And it presents itself to the outside world through what we're going to call like a data model or a data architecture, right? Those models are selfishly targeted towards our internal stakeholders within the domain first. So they have to serve the domain first. And then as a next step, they can serve the integrated kind of use case for multiple domains inside your organization. And that's why also a layered architecture makes sense, because you can actually think now of the integrated layer as something that's not going to only be fit for here, but also fit for those external products. Again, you will prioritize those first, but then you can look at external products and see how can I model or architect my integrated layer in terms of even like data models, physical models, that would serve both of those use cases. You can use AWS Lake Formation to simplify managing data lakes for you. And right now you can access Amazon Data Zone in private beta to actually start doing this marketplace kind of experience, ease the consumption and production of data. What are the challenges to watch out for? I think those are typical challenges that you've heard a lot about, like systems that are trying to scale. But first, make sure that those domains are like they're encapsulating things inside them, but they are not running as their own silos, right? They have to also know what's expected from them from a governance perspective and how they're going to integrate with other domains. And they also have to adhere to some of the things that we say, right? So don't also try to have domains that are trying to aggregate everything inside them, because that will be your bottleneck. It's not just modeling, which is a big issue for analytics. It's going to also building consumption experiences for everyone who's trying to consume the data out of those aggregates. So be purposeful about integration. make it work from a use case perspective, and know who's going to consume those use cases perspective before you go with that kind of architecture. And if I cannot stress that enough, but govern your domains for those open and interoperable integration data layer. That's going to be the key for you to flexibly move forward. Right, is this the end of story? Well, we have seen an evolutionary architecture, and now we can put some other names on top of those steps, right? We've removed the ingestion burden as a first step, because that's the thing that's going to drive people to look for alternative data sources or alternative platforms all across your organization and lead to this questionable experience for insights. Then, once we make the data available, we need to look at the consumption experiences. And we're going to build on top of what we learned at the first step in order also to provide good consumption experiences for our users based on the expectations that they have. But finally, we're going to build on those two things in order to deliver a distributed data platform. And there is actually like very little evidence that going here will solve your problems down there. Make sure that you address those problems first with good analytical architectures first before going to any distributed model. So, a data platform today is expected to do a lot of things and to integrate a lot of things. But working backwards from your customer, that's the only thing that's going to lead you to a happy organization and happy Barbara, Buzz, and Tony, right? So there is a bunch of resources, but what you can do is actually scan this QR codes. This is just a 4-click survey. Once you go through that, you're going to have a link to the slides. And also, there is a feedback. So if you want to hear about different topics or if you have any feedback, just provide that in that box. Thanks. And I think we have 10 more minutes. So anyone wants to have any questions? All right, so I think with that, we can end the session. I'll be hanging around anyway in the breaks, so just use me as an Ask an Architect experience or anything. And thank you for coming for today's session.